This lecture will discuss the importance of image intensification and its application in the fluoroscopic setting. Fluoroscopy prior to the invention of the image intensifier by Edison produced dynamic imaging that was very dim. It replaced the conventional fluorescent screen. This dimness made it very difficult to see for the radiologists. The image intensifier is as the name implies. It will intensify the image and in this case increase the brightness many times over. It is like walking into a room that is completely dark. It takes a few minutes for your eyes to adjust so that you can see. This is what occurred with radiologists prior to image intensification. Think about how difficult it is to read a book in a dimly lit room versus having a lamp over that book. The brightness of a screen is measured in the units of lux. The typical brightness of a normal radiographic image is 100 to 1000 lux. The eye is able to bring the brightness of fluoroscopy to the same level as a normal radiographic film. Now, why is the image so dim in fluoroscopy without image intensification? Fluoroscopy is performed under low MA settings. Your MA settings control image intensity or brightness. That's why the image appears dim. However, we cannot just up the MA because exposure time is long, which is what makes patient exposure so high in fluoro. The image intensifier is made up of several different parts. The image intensifier converts X-rays into visible light that is visible on the screen for the person to see. The tube itself is very similar to an X-ray tube and contains both a cathode and anode. It is made up of a glass envelope that supports the internal structures. It is vacuum sealed as well to prevent any interference from air molecules. I'm going to start the explanation of the image intensification process from the output to the input side of the tube. The remnant X-ray beam exiting the patient's body will first interact with the input window, where the X-rays are converted to visible light by interacting with the cesium iodide. Cesium iodide is a type of crystal that will fluoresce when exposed to X-rays. They are packed tightly together in a layer. This input phosphor layer is sandwiched between the input window and the photocathode. The light produced by the cesium iodide interacts with the photocathode next. The photocathode is made of a layer of metal comprised of antimony and cesium. When stimulated by light, it goes through a process of photoemission. This is the emission of electrons by light stimulation, similar to thermionic emission but through light. The electrons are then accelerated to the output phosphors, which is on the anode side of the tube. These electrons are focused to the output phosphor by the electrostatic focusing lenses. The electrons produced at the photocathode are referred to as photoelectrons. These electrons are moving towards the output phosphor, which is made from a zinc-cadmium sulfide. The interaction between the photoelectrons and the output phosphor produces light, which comes out as the visible image on the monitor. Each of these photoelectrons are able to create 50 to 75 times more light photons. This is what creates the step up in the brightness levels on the screen. Now I'm going to review everything which I just went over in a few steps to end this lecture. Follow the diagram as I explain these steps. The remnant X-rays will move towards the input window first, interacting with the input phosphor. The input phosphor will now convert the X-rays into light. Next, the light produced will interact with the photocathode. The photocathode produces electrons by light stimulation through the process of photoemission. The photoelectrons are accelerated due to a potential difference and are focused to the output phosphor by the electrostatic lenses. Finally, when the electrons react with the output phosphor, light is produced as a visible image on the viewing monitor. During this step, it is important to understand that for every single photoelectron, it could produce many more light photons, and this is how the image is brightened.